Hey guys, today's our last day of notes for all of Unit 2. We're just going to finish up 2C. Now, 2C again is applications of trig ratio. So really all we're doing is word problems. The hardest part with word problems is knowing which angle it's talking about. Remember on the video yesterday we talked about angles of elevation and angles of depression. So angles of elevation go up from the horizontal and angles of depression go down from the horizontal. So if we look at example 2, I want to identify my angles of elevation and the angles of depression. Well, angles of elevation go up from the horizontal, right? So horizontal is a straight line across, right? So here is an angle of elevation. So angle 2 right? And then again here I have a horizontal and I'm going up from that, right? And angle 4. Again, the biggest thing is to start at the horizontal. Then, for my angle of depression, right, I have an angle here. Right, and I have a horizontal here, and I'm going to fix that. But right, I have that angle there. So it's angle 1 and angle 3. Okay. So this is a very important distinction to make when you're reading your problem. Make sure you know which angle it tells you. Alright, let's look at our second example here, or example 3 actually. It says a 12-foot long ladder is leaning against the wall and makes a 77-degree angle with the ground. How high does the ladder reach on the wall? Down to the nearest inch. Right, so I'm going to draw my wall and my ladder leaning against it. And so this makes a right angle. So I know I have a 12-foot long ladder. So my ladder's here leaning against the wall, so that's 12 feet long, the whole ladder itself. And then it makes a 77-degree angle, right, with the ground. So this is my 77-degree angle. 77 degrees, okay. We'll just write that together. So then I want to find how high does the ladder reach on the wall. So what I'm looking for, right, is the height. Okay. Once I get here, I'm simply setting up my trig ratio. If you don't know at this point SOHCAHTOA, that is a problem. I said at the very first day of this unit that you are going to have to memorize SOHCAHTOA. You are going to have to know exactly which trig ratio goes with which side. You still have to do that. We have done so much practice with it in class, in the notes, on the quiz, right? And some people lost points on the quiz because they don't even know which trig ratio to use. You have to know the trig ratios in SOHCAHTOA. So here I have my opposite side and my hypotenuse, and then my adjacent side. If you also can't tell me which side is opposite of the angle, that's a large problem too, right? Opposite means it's across, it doesn't touch it, right? So I have an O and an H, so I'm going to use sine. So sine of 77 degrees equals x over 12. Okay? In order to solve for x, right, I just have to multiply by 12. So then x equals 11.6924 or really 11.7, right? Just typing that into my calculator. So we get x equals 11.7. Why is it jumping? Oh, there's nowhere near anything. All right, let's look at our next problem. So to approach the Sonoma Airport runway, the pilot of an airplane must begin a 4-degree descent starting from a height of 2,805 feet above sea level. The airport is 102 feet above sea level. The nearest thousands calculate how far from the runway the airplane has to be. It starts with descent. Okay, this is a very important problem because it's very hard to draw. So here's my little airplane, right? And the airplane is 2,805 feet above sea level. Right? So then he has a descent, right, of 4 degrees. So again, this is a descent, so this is a depression. So I actually have to draw the horizontal line because angles of elevation and angles of depression go from horizontal lines, right? So this is 4 degrees. This is the descent. And then, right, the airport itself is 102 feet above sea level. Right, so I can't go draw it down at the bottom, right, because it's not at sea level. It's somewhere along this line. Right, so that's like 102. So I want to find, right, how the distance from the airport. The easiest way to do these types of problems is to draw a rectangle. I already have 3 sides of a rectangle because I do that horizontal line, I have this horizontal line, I have this vertical line, so I'm going to draw this vertical line. Okay? If my airplane is x feet away from the airport along the ground, then he's also x feet away from the airport in the sky, right? If we just kept going straight. Those are the same. The same thing with the height here, right? Now this height we have to be careful of. The entire height from start all the way to sea level is 2,805, but I have to go back 102 because my airport isn't at sea level. So my airport is really at, subtract 102 from this, 2,703 feet, okay? So now in order to solve this problem, I'm just going to look at this triangle. Okay. This is my right triangle I'm looking at. So if you look here, right, this is my angle. I have opposite sides and adjacent sides. So I'm going to be using tangents. So the tangent of 4 degrees equals 2,703 over x. This is another problem I saw on our quiz when we were solving. We have to multiply by whatever's being divided, by whatever's doing the dividing. Right now, x is doing the dividing because it's in the bottom. So I have to multiply by x. So I have x times the tangent of 4 degrees equals 2,703. Right? Now to get x by itself, I divide by the tangent of 4 degrees. So x equals 38,654.7. A big number, which makes sense because our angle is actually really small, right? So in order to get that far, you have to go a long way. All right, let's look at our next example. Alex stands at the top of a cliff 82 meters high. My cliff is 82 meters high. Here's my cliff. And see the ship 1.8 kilometers out. So my ship is on 1.8 kilometers, which, right, is 1,800 meters. So I'm going to ignore the kilometers and put it in meters because this is in meters, right? Like my board's off. Okay, so my ship is 1,800 meters away. Now I want to determine the angle of depression between the ship and Alex. Well, right. So remember, angle of depression goes from the horizontal. So I want to find this angle. Okay. So again, I'm going to draw my rectangle the same way, right? If the bottom's 1,800, the top's 1,800. If that side's 82, this side's 82. Okay. Now I can find my angle, right? Again, I have the opposite side and the adjacent side. So the tangent of theta equals 82 over 1,800. I'm going to do the inverse tangent of both sides. So I get theta equals 2.6 degrees. So it won't be around the next degree. So theta equals 3 degrees. So it won't be around the nearest degree. All right, last example. You stand 40 feet from a tree. So here's my tree. Here's me. Here's you. Right? So you stand 40 feet from that tree. Now, the angle of elevation from your eyes is you're 5 feet above the ground. So we're 5 feet up. So then the angle of elevation is 47 degrees. So now this is elevation. So I'm going to go from this horizontal from my eyes and go up to the top of the tree. That's 47 degrees. I want to find how tall the tree is. Okay. So I'm still just finding, well, I'm finding that whole height. Now again, since my feet are 40 feet away from the tree, my eyes are also 40 feet away from that tree. So I'm going to start by solving for this, and I'll call it y for now, right? Because I have to use this right triangle. So this is again is tangent. We have a lot of tangent problems today, right? Opposite, adjacent. So the tangent of 47 degrees equals y over 40. Multiply both sides by 40. So y equals, we get 42 linear foot, sorry. So that'd be 43 feet, right? So this part of the tree is 43 feet. I have to add in this part of the tree, which just like us is 5 feet. So we're going to add 5, so x equals 48 feet. Alright, that's it for our word problems, and that's it for our notes for KC2. Have a good night.